The second video on equations of straight line graphs. Starting with parallel lines. Well, parallel lines means they're in the same direction, so they must have the same gradient. Now that's not always apparent at the start from looking at the equation, but if we rearrange it so that both equations are written in the form y equals mx plus c, then that should work. This one already is y equals minus 3x minus 1, gradient of minus 3. This one, if I move the plus 3x across to the other side, it becomes minus 3x, so I get y equals minus 3x plus 4, or 4 minus 3x. Doesn't matter which way around, but it's the minus 3 is with the x, so that's the gradient here, and here's the gradient is minus 3. So the first one had gradient m1, and the second one has gradient m2. We can say if they're parallel lines, then m2 must be the same as m1. The gradients are equal. If we actually have a look at the sketch of the lines, you'll see that the two lines are parallel, and you'll see the gradient is minus 3. If I take y equals minus 3x minus 1, you'll see that you're going 3 down for 1 to the right, gradient is minus 3, and then minus 3x plus 4. You'll see that, again, 3 down for 1 across, so the gradient is minus 3 each time, and they're parallel. Perpendicular lines. Now again, if we want to look at it in the form y equals mx plus c, it will help. This one's in that form. This one needs to be rearranged. So if we take the plus x minus 9 to the other side, you're going to get 2y equals minus x plus 9. Now divide through by 2, and it's y equals minus a half x plus 9 over 2. Leaving it as a top-heavy fraction is normally best when you're doing this, but you could have written 4.5 if you wanted as a decimal. And in this case, you'll see that the gradients are different, and one of them is what's known as the negative reciprocal of the other. And that means that instead of having a gradient of 2, what I do is the reciprocal, 2 turns into 1 over 2, the negative reciprocal is minus 1 over 2, minus a half. If I did it the other way, I would do the reciprocal of a half is 2 over 1 is 2, and the negative of reciprocal of minus a half becomes minus minus 2, which is plus 2. So in each case, it's the negative reciprocal written down like this. m2 is minus 1 over m1. So again, you take the 2, make a reciprocal as a half, and then multiply by the minus sign, make it minus a half. Okay. Then here, if we have a look at what's happening on the graph, you'll see that they do look at right angles to each other. And if we check for y equals 2x minus 3, that's gone up 2 for 1 across. But for the other one, it's going the negative direction, sloping top left to bottom right. And you'll see that it's 1 going down 1 for 2 across, down 1 to 2 across is a half, negative direction, gradient of minus a half. Let's answer some questions. First, midpoint of a line segment first, then answer some questions. So, midpoint of a line segment. Well, what we do to find the midpoint is you find the average of the x coordinates and the average of the y coordinates. Now that can be written like this. To find the average of the x numbers, you go x1 add x2 and then halve it. For the y ones, y1 add y2 and y2 and then halve it. So in this particular case, what we've got are x coordinates are minus 2 and 4. So if we add them, you get plus 2, halve that, you get 1. And then for the y coordinates, you do y coordinates are 1 and 4. So to find their average, 1 add 4, 5, divide by 2, 5 over 2, or 2.5. And you'll see that that is at the midpoint of a line segment. Now, a line segment, if you wonder why we've got segment there, is a straight line goes on forever. A line segment is one where it has got a very distinct length. It just goes from A to B. It doesn't keep on going. So that means it's a line segment. It's part of a line. Now, the length of a line segment. For this, we use Pythagoras' theorem. Now, that can be written down as x2 minus x1 squared plus y2 minus y1 squared is equal to the length of a line squared. But it's easier if we actually have a look at this and we do an example on it. Now this one is going from A, has got coordinates minus 2, 1, and B is 4, 4. It's the same line as here. And so what we do is we want to find x2 minus x1. Now that is 4 take away minus 2, 4 take away minus 2, 4 plus 2, 6. And then y2 minus y1 is 4 take away 1, 3. And then we've got to use Pythagoras on it, so it's 6 squared add 3 squared, 36 add 9 is 45, and AB, of course, is the square root of AB squared, so what we do is we just get the square root of 45. Intersecting lines. Now, if you want to find where two lines intersect, you solve them as simultaneous equations. So, for instance, if we have y equals 3x minus 5 and y equals 10 minus 2x, this is the easiest type. You can just say, well, the y's are the same, so 3x minus 5 is y, so 3x minus 5 must equal 10 minus 2x, because that's also y. So you get 3x minus 5 equals 10 minus 2x. Move the 2x across, you get 5x. Move a minus 5 across, becomes plus 5, you get 15. So 3x plus 2x is 5x, 10 plus 5 as it moves across, changes sign, 15. So x is 3. If x is 3, we can go to either of the lines to find y. If I go to the first one, y is 3 lots of 3, take away 5. 3 3's 9, take away 5, 4. So the y coordinate is 4. So they're intersecting at the point 3, 4. Okay, and you'll see the lines over here. They are intersecting at the point 3, 4. Now, whenever you do a solution of simultaneous equations, it's always worthwhile slotting the numbers back in right at the end just to check they work, just to make sure there's not been a mistake. So if I do this one, I get y is 3 lots of 3, 9, take away 5, does come to 4. This one, y is 10 minus 2 lots of 3, 10 minus 2 lots of 3, 10 minus 6 is 4. So it has worked. Right, let's do some questions. First, find the equation of the line parallel to 3x plus 5y equals 7, which passes through the point 2 minus 6. The first thing we say is you've got 3x plus 5y is 7. Let's find the gradient of this line by making y the subject. So if I move a plus 3x to the right-hand side, I get 5y equals minus 3x plus 7. Divide through by 5, and I get y equals minus 3/5 x plus 7 over 5. And that means my gradient is minus 3/5. So the parallel line must have the same gradient. So the gradient for the parallel line is minus 3/5, but it goes through the point 2 minus 6. Well, if you know the gradient and you know what point it goes through, then the equation is y minus y1 equals mx minus x1, a really important equation to know. And so we can instantly now write down the equation, and so you get y minus 6, that's y plus 6, equals the gradient minus 3/5 x minus 2. Y plus 6, y plus 6, y minus 6 is plus 6, equals the gradient minus 3/5 x minus 2, and you can leave that as your answer. Next one, find the coordinates of the point of intersection of these two lines here. 2x minus 3y equals 14 and 5x plus 2y equals 16. Again, it's simultaneous equations, but they're set out a different way. Well, the easiest way to do one of these is to make either the number of x's, the coefficient of x is the same, or the coefficient of y is the same. So we want the number of x's the same or the number of y's the same. It's easiest to do this by the y's. So if I double this entire equation, I will get 4x minus 6y equals 28. And if I treble this equation, multiply it by 3, I get 15x plus 6y equals 48. You see that I've got here, it's not actually, I've not got exactly the same coefficient, because this is minus 6y and that is plus 6y, but it doesn't matter that we've got it with different signs. So effectively I'm saying 6y is what matters. Now eliminate y's. Now what you need to do is say, what do I need to do with these two equations over here to get rid of the y's? Well, if I add minus 6y and plus 6y, the y's disappear. That's what I'm trying to do. So I will add these equations. So I get 4x add 15x is 19x, minus 6y add 6y disappears, 28 add 48 is 76, divide through by 19 and you'll find that x is equal to 4. And now to find y, I can go to either equation to find y. I've gone to this one here, and I say 5 lots of 4 is 20, 20 plus 2y is 16. That means 2y is 16 minus 20, 2y is minus 4, y is minus 2. And again, I'm going to check it in both the equations. So I've already done it from that equation, but looking over here, 2 lots of 4, 8. Take away 3 lots of minus 2, or minus 3 times minus 2 is plus 6. 8 plus 6 is 14, so it has worked in the other equation. So where do the lines intersect? They intersect at the point 4 minus 2. So always it says find the coordinates of the point of intersection. Don't just stop here, write them as coordinates 4 minus 2. Next ones. A and B have coordinates minus 5, 4 and minus 1, minus 2 respectively. Find the length of AB. Well, the length is Pythagoras' theorem, so AB squared. We need to find the difference between the x coordinates and the difference between the y coordinates. X1 first. Minus 1 take away minus 5. Well, minus 1 take away minus 5, minus 1 take away minus 5 is going to come to minus 1 plus 5, which is 4. So AB squared will be 4 squared. And then for the other part, I've got minus 2 take away 6, take away 4 is minus 6, but I'm squaring minus 6. Be careful here, you've got to get plus 36. So you're squaring minus 6. So we get 16 add 36 is 52, so the length of AB is the square root of it, square root 52. Next bit, part B, find the equation of the perpendicular bisector of AB. Well, I think it's easiest if we just do a little sketch, doesn't need to be big. There's AB, my 2 points, doesn't really matter where they are. I want the perpendicular bisector. So the perpendicular bisector is at right angles to AB, and it goes through the midpoint of AB. Bisect means cuts it in half. So it's cutting AB in half, so that's the midpoint, and it's got to be at right angles. So we've got two things. We need to find the gradient of this line. That means find the gradient of AB, and then the gradient of the perpendicular line, and we also need to find that point M, which is the midpoint of AB. So let's do a gradient first. The gradient of AB, right? So the gradient is the increase in y divided by the increase in x. So it's minus 2 take away 4, and minus 1 take away minus 5. Notice I'm being consistent. Minus 2 take away the 4 on the top, minus 1 take away the minus 5 on the bottom. I could instead have done 4 take away minus 2 on the top, and then minus 5 take away minus 1 on the bottom. It's up to me which way round I do it. I've done it this way. So minus 2 take away 4 is minus 6, and minus 1 take away minus 5 becomes minus 1 plus 5, which becomes 4. So I've got minus 6 divided by 4, which cancels to minus 3 over 2. The perpendicular gradient is its negative reciprocal. Now, the reciprocal of 3 over 2 is 2 over 3, just swapping them over, and negative reciprocal I multiply by minus 1, so minus times a minus makes a plus. So effectively I'm going to get minus times a minus plus reciprocal of 3 over 2, 2/3. So M2 is 2/3. That's my gradient of a perpendicular line. Now the midpoint. The midpoint of a line is the average of the coordinates, the average of the x coordinates, the average of the y coordinates. Okay, so midpoint of the line, that was here, the average of the x coordinates, average of the y coordinates. So if we go back, I probably would have been better not doing that, because let's just get back to my 2/3 again as my gradient. That's how we got it. There was the sketch. So for midpoint, the average of the x-coordinates, -5 add -1, that's -6, divided by 2 comes to -3. And then for the y-coordinates, 4 add -2 is 2, divided by 2 is 1. So it's -6 divided by 2 is -3, 4 add -2 is 2, divided by 2 is 1. So that's the coordinates here. So the equation of a line, there's my gradient, there's the point it goes through. As always, y minus y1 is m brackets x minus x1. So y minus 1 equals 2/3 x plus 3. Y minus 1 equals 2/3 x minus 3 becomes x plus 3. There's our equation. Okay, so good luck with your work.